So bear with me for a bit. Okay, so before I begin the webinar formally, I would just like to give everyone a brief introduction of myself. My name is Regine. I'm from Singapore, born and brought up there until 2016 when my husband and I left Singapore for his work. So I was trained in the Seoul Teacher College in Singapore. There's only one teacher college in Singapore because it's really small. By the way, for those of you who were with me in the last webinar, if you want to go and grab a drink or what and come back because you've heard me introduce myself, just feel free to do so. Okay. So I have been a teacher since 2006. I started my teaching career in Singapore until, so I mentioned 2016. So I have been overseas outside of Singapore since 2016, teaching in different private, international, and even public schools of the countries we've lived in. So I have taught a small number of other curricula, Cambridge International Baccalaureate, the New Zealand curriculum, all right, and of course, Singapore mathematics curriculum. So the reason why I decided to start sharing online is after helping a school that I was hired to help overhaul the Cambridge math curriculum to Singapore mathematics curriculum. So the school was still using the Cambridge curriculum, but they were using the Singapore materials to teach, the Singapore pedagogy as well as the whole structure and the scope and sequence or the syllabus. All right. I helped the school raise their attainment level from some levels below national average to all levels above national average within 1 year of implementation through coaching, mentoring, co-teaching. And I thought if I was able to help one school outside of Singapore do this, I can actually help a lot more people achieve this with their own children and their students. So that's why I started sharing online. I may not be able to help everyone in the world, but I believe in the starfish story that if you throw one starfish back into the sea, you're saving one at a time, right? So making a difference to whoever I can help. Excuse me. So just a quick note that within these 2 hours, it's really impossible for me to cover the whole syllabus of grade 1 Singapore mathematics curriculum. So I'm just going to focus on 5 very important, what we call big ideas in grade 1 mathematics, right? So I like to look at mathematics from elementary to high school as building a house. When building a house, we know that we need to start from a foundation, right? In the Singapore mathematics curriculum, grade 1 is the foundation of a child's mathematical learning journey. Grade 1 is not just simply learning how to calculate. Oops, sorry. It is about developing strong number sense so that children understand how numbers work. Every topic introduced in the grade 1 every topic introduced in grade 1 becomes a building block for more advanced mathematics concepts to be built on. Rather than teaching skills in isolation, the curriculum continues to visit and extends these concepts throughout the primary years, which is a characteristic of a spiral curriculum. So before we explore the key foundational ideas in mathematics, grade 1 mathematics, it is helpful to understand the prerequisite skills children need before they begin formal mathematics in elementary school, right? So this is taken from Singapore's latest primary mathematics syllabus from primary 1. Primary 1 is grade 1 in Singapore to grade 6. And this is, if you are curious to look at Singapore's primary mathematics syllabus, this is easily accessible online. You just go and Google MOE, Ministry of Education, Singapore, primary mathematics syllabus, and you have access to this document as well, right? Excuse me. All right, so here are the few prerequisite skills that children should be equipped prior to grade one, because they need these skills. Even though grade one is considered as the foundation level in Singapore, and some people are really curious to know, why does Singapore only start formal teaching and learning of mathematics in grade one and not kindergarten or even preschool? So that's because studies have shown that children are cognitively, well, generally speaking, because there are always exceptions. So generally speaking, most children are only ready at the age of 6 to be able to reason, to be able to understand more abstract concepts. So that's the reason why we'll just delay the formal teaching and learning of mathematics in Singapore until the age of 6, which is grade one, right? So yeah, matching. These are very simple tasks that children are capable of carrying out at home, in school, all right? Counting, get children to count as they walk, as they take steps from maybe the bed to the bathroom, or from the school desk to the door, all right? So just get them to practice these very simple tasks. Get them to count the number of leaves or pebbles they find while going on a nature walk. All right, sorting toys, I'm sure they do that, unless they have someone to do it for them all the time. All right, so have children do very simple household chores. It's good for them. It helps them to develop like psychomotor skills as well. Okay, compare anything, compare size, how one t-shirt is bigger than the other. All right, you don't have to get them to tell you how many more. They do at the age of 5, before they start grade one, they're not required to be able to tell you the quantity greater or lesser than another quantity. All right. And then recognizing patterns. Children love doing art and craft, so perhaps you can get them to make a bracelet with 3 different colors: red, black, white. Okay, and then repeat the pattern. So these are just some fun and simple ways to help them develop prerequisite skills before they start learning mathematics formally in grade one. So I talked quite a bit about number sense in my Instagram, as well as one of my slides earlier about building a strong foundation. Okay, so what exactly is number sense? Number sense has 4 criteria. So it requires 4 criteria to fulfill the definition of number sense. When a person's intuitive understanding of numbers, they understand the numbers, their relationships, how they can be used flexibly and efficiently. All right, so a child with strong number sense doesn't just know how to perform calculations. They understand why numbers work the way they do and think about numbers in different ways. So number sense is the foundation of mathematics. Children who develop strong number sense, they are capable of learning new concepts more easily, become fluent and flexible thinkers, solve problems more efficiently, and much more, right? So with what happens when a child lacks number sense? That's when they will resort to memorizing rules and procedures, which can make mathematics increasingly difficult as concepts become more complex, because then they won't be able to apply if they're not given the opportunity to, if they're just memorizing how to perform algorithms. And usually, all right, not all the time, usually when a child has developed number sense, fluency tends to follow, with some exceptions. So fluency is not just talking about speed, okay? It is about understanding numbers well enough to solve problems confidently using methods that make sense. So when a child is fluent in math, the child is able to work efficiently, accurately, and flexibly. If we're just looking at the example of a child being able to recite the times table, when asked what is 6 times 7, the child is able to tell you 42, but is not able to use that to find out what is 14 times 6, which is double of 7 times 6, all right? Then that child is probably fluent in his or her 6 or 7 times table, but is not developed in number sense, okay? So many people think fluency means know times table quickly or doing calculations fast. While efficiency is one aspect, true mathematical fluency also includes accuracy, flexibility, and reasoning. So what does mathematical fluency look like? A child who's mathematically fluent will be able to recall basic facts accurately and efficiently, choose the most appropriate strategy for a calculation, adapt strategies to different situations, explain why a strategy works, estimate whether an answer is reasonable. Right. I forgot to mention, but we will have a 10-minute break, probably at the 1 hour mark. Okay. I know some of you are, it's nighttime for you. Maybe you get sleepy if you were to sit through this whole 2 hours block. So we'll have a break afterwards. Okay. So now we're going to start on the first foundational ideas. I have sequenced the foundational ideas like how we will teach it in the Singapore mathematics curriculum. All right. So before comparing numbers, children would have learned how to subitize. So subitizing is to be able to tell the quantity of a number of the quantity of items if they were to be provided with, let's say, 5 cubes, okay, in a certain pattern. So when a child is presented perhaps a 10 frame, 10 frame is like a table with 10 boxes, 5 on top, 5 below, okay? So if presented with a 10 frame and a 5 counters across the top row, a child should be able to tell that is 5 counters. So that is an example of subitizing without having to count 1, 2, 3, 4, 5, all right? And then after subitizing, that's after they learn to count. So they need to learn to count first and then be able to subitize, all right? And then after that, they will learn to compare numbers once they know how to identify the quantity of items, all right? So I'm skipping counting and subitizing. So why are they important in grade 1? Because we need to be able to compare, all right, to make decisions. So children need to compare greater than, less than, equal to, which also talks about the concept of same as. Be able to tell the difference between numbers, which I'm going to demonstrate afterwards, how to go about teaching that, all right, and also ordering numbers, ordering from small to big or big to small. So they begin to understand the magnitude, not just how to count, but how much bigger or smaller one number is than another in grade 1. So why does comparing numbers matter? It matters because this skill is required in these concepts that they will learn at higher level. All right, so estimation, rounding, these start, so these are required from grade 3 onwards in Singapore math curriculum. All right, and then decimals, grade 4, percentage, grade 5, negative numbers, grade 6, and so on. No, actually, negative numbers is secondary 1. All right, in Singapore, we actually don't do negative numbers in elementary school. So, children who understand magnitude are also much better at judging whether the answers are reasonable. So children before the age of 8 or before grade 3 primary 3, okay, you will see that it is quite natural for them to not be able to tell whether the answers are reasonable when asked to add, let's say, uh, 300 and 500. If the child accidentally writes an extra zero, which makes it 5,000, it's normal because they still don't have a very good perception of how big or yeah, how large the quantity is. But this is they are expected to be able to tell whether the answers are reasonable or not once they start learning how to estimate and they have had enough years, grade 1 and grade 2, practice identifying quantities, recognizing how big 100 is, 1000 is, 1/10, and so on. All right. So these are just some examples of manipulatives that you can use or we use in teaching comparison in Singapore mathematics. All right, so um, the ones that I have an asterisk on, like linking cubes and base 10 cubes, are ones which um, I think would be good to purchase because it really helps the children see the quantities when, especially for base 10 cubes, when they're learning place value, right? Um, I hope you all have seen my post about the recommended manipulators. You don't have to purchase 10 frames. You can make your own number strips. Okay, there are people who purchase 10 frames because they come on magnetic board and then you can stick the counter onto the 10 frames. But it's really not necessary. You can even do that on a whiteboard that has stainless steel back, right? Much cheaper than expensive manipulators. I'm so phlegmy in the morning. I'm sorry. Okay, so comparing numbers, children need to first learn to compare using greater or smaller. So how comparing numbers start would be having children count the number of, let's say, cube in this case. Of course, it's good to expose them to count different things. So it's even good to get them to count, let's say, three three soya beans and three uh, spoons. All right, and then let them see that three of certain item, which is smaller in size, although it has the same quantity, can look quite different when it comes to the physical size, right? So they will count each group of items and decide which is greater or smaller. So in this case, you see that um, we have I have deliberately arranged this row and this row side by side, one on top of each other, so that it's easy for them to see that this is significantly longer or greater than the second row of cubes. And then they will learn to compare how many more or less. Okay. It's important to have children start with comparing items in an orderly manner, like what I've illustrated here. Um, then after they have had enough practice looking at comparing numbers this way, you can get them to compare it in a less orderly manner. So now I'm going to switch the screen to another app, okay, called Polypad. Give me a minute, please. So you before we as teachers or parents teach the child to compare the number of items, for example, um, here on the right hand side, we have 6, and we're comparing 6 counters to 5 counters. We will actually have to get the children to compare by counting first and then deciding which is more. All right. So only after they have the skill of knowing and identifying which quantity is larger or smaller, bigger, greater, fewer than, then we will start getting the children to compare and determine the number that is more or less between two quantities. So we have 5 counters in this time frame on the left and 6 counters in this time frame on the right. All right. So what we usually would do when we get them to compare the number of counters in a 10 frame is we can get them to move one of the 10 frames underneath or above the other, and they can see if you were to get them to, match that both numbers 5 and 6 have at least 5. So what is the extra number of counter that one has more than the other? So they see that this is more. Okay, this is one more than this number here. So 6 is more than 5. All right. So that is how we can get them to compare using 10 frames. I also have the reckon rack over here. All right. So you can get the reckon rack from additional tools. If you would like to use polypad, this is recommended for teachers who are teaching in the classroom, and if you need to show and do any demonstration on the whiteboard. All right. I would encourage everyone to be using concrete manipulatives instead of two-dimensional manipulatives like these virtual manipulatives as much as possible. All right. In fact, I would recommend this only after children have had the opportunity to play with concrete materials for a substantial period of time. So coming back to the reckon rack, if you notice, each row of beads resembles that of the number of space available on a 10 frame. All right. So children, if we were to expose them to the use of 10 frames with counters in it, since the start of learning how to count, since the start of their formal teaching and learning math journey, they will be able to see in the 10 frame in the first row that it can occupy 5 counters. All right, or 5 counters can occupy these 5 spaces. So therefore, one look for any child who is already proficient in subitizing, they should be able to tell this is 5, all right, and then there are 5 over here. So because they have been exposed to the use of 10 frames so much, they should be able to conclude that altogether each row of reckon rack has 10 beats, 10 counters. Okay, so we can have the child show us 5 and 6 on the reckon rack, and then we get a cardboard or a piece of paper and cover the rest that they don't have to be distracted by. So now it's very obvious that when comparing 5, we can write the number next to it if you have a whiteboard behind the reckon rack. Okay, 5 versus 6. 6 is obviously more than 5. And how many more? 6 is one more than 5. All right. So after we have introduced them to the use of concrete materials and they have visually seen the difference between the two numbers, we can have them write if they're good at writing. If not, we can get them to fill in the blanks, okay, with the numbers. So perhaps you can start with what is blank more than another number. So you can guide them, all right? And then of course we'll have the opposite. It's always important to expose children to the opposite, like when we teach, after we teach subtraction, we always teach after we teach addition, we always teach subtraction. After we teach multiplication, we always teach division. Okay, so they need to know which is more. They also need to know which is less. And then you guide them and ask them which is more. Then they should be able to write 6 is more than 5. So you don't ask them how many more first. You ask them to compare and tell you which is more first. Then you can ask them how many more. Okay, so 6 is 1 more than 5, and so on. So 5 is 1 less than 6. Number bonds. All right, so why are number bonds important? So number bonds help children see that numbers can be broken apart and put back together in different ways. In other words, if you have seen one of my Instagram posts, you notice that I use the words compose, decompose, recompose. All right, so children need to be able to see that numbers are not just a symbol. They can be quantities that are able to be broken up and put back together to form the same number or different numbers depending on the situation. Right? So instead of memorizing facts, children develop flexibility with numbers when they are given the opportunity to learn how to break and put numbers back together. They begin to recognize relationships between numbers and perform mental calculations efficiently. So I'll use the number bonds to do a couple of demonstration afterwards, okay, in addition and subtraction. So children who are proficient in number bonds will be able to recall basic facts quickly, all right, calculate mentally without relying on fingers, understand compensation strategies, which is what I'll cover afterwards in addition subtraction, develop fluency instead of rote memorization. So I'm showing this image because this is what I plan to use, but I tried doing it with my laptop camera facing the items, and it just didn't turn out the way I want it to be. So I'm just gonna explain to you what you can do to introduce number bonds to your learner. Okay, and I'm going to change the screen back to polypad. I get confused. Okay, I'm changing it back to polypad. All right, so imagine this number bond that I've drawn on polypad are the cups. Okay, so imagine these 3 circles are the cups that I showed in my PowerPoint. And these 2 lines are the halves that you're going to cut from a paper towel roll. All right, so after you're done using your paper towel at home, you can keep as many as you need, right? And cut them into halves. All right, so imagine this is the paper towel roll. You cut it, you cut it longitudinally into halves, and you will lay them between these 2. Okay, so you lay one between these 2 cups, and then you lay another between these 2 cups. All right, to show how a number bond is physically. All right, because the reason why I'm suggesting this is because if we don't teach the children this way, you will see that, all right, the moment you ask the children to fill in the circles with the correct numbers, they are going to give you answers like this. So let's say we want to find the number bonds of 5. Instead of putting 5 here, which we all as adults, we know 5 should come in here, all right, you're going to start seeing answers like this. All right, because they don't understand what these lines are. They don't understand what this entire abstract looking balls and lines are. So it will be good to give them the opportunity to physically move. All right, so again, let me remove this. Okay. Let's say we want them to decompose or break up 5 to form number bonds. So we get them to pick out 5 cubes, 5 counters, 5 pom-poms, whatever you have as counters, right? So they will take it out themselves. Don't take it out for them, right? So that they can also practice counting 5 and seeing how 5 looks like. So then you will put the counters into this gray cup. Okay, imagine they are cups, all right? So put it into the cup, get them to put it, not you put it, sorry. And then ask them to shake gently and pour it down this half of the paper towel roll. All right, whatever comes out will go into this cup. And then ask them how many cubes, let's say it's cubes, how many cubes are there in this cup? And then perhaps they will have 2 cubes in this cup. All right, so then you can draw a number bond like this again, draw this number bond on a whiteboard on a piece of paper, and then you ask them to fill in, and you tell them that imagine this is a cup that you put all your cubes into, and this is a cup that you just pour your cubes into, your 2 cubes into, right? So how many number of cubes did you start off with in this cup? They will write it themselves, okay? And then how many cubes did you have after you pour it into this cup? Then they will write, okay? So let's say they started with 5, and then this is 2. And then you ask them, how many cubes did you pour from this cup into, and then you use your finger and you trace. Imagine this little hand, my cursor is your finger, and then you trace how many cubes from this cup did you pour into this cup. All right, and then they should be able to tell you 2. All right, it's very easy for them to see 2 because they should already know how 2 looks like, how 3 looks like, how 5 looks like. All right, and then obviously there will be some more cubes in the cup remaining, and then ask them to pour the rest of them down this other half of the paper towel roll into this cup, and then have them write the number of cubes that they poured into this cup. Okay, so this is a very I find it is an effective way to help children understand what these lines are when they are asked to draw their own number bonds, right? Because if they don't do it that way, then they don't see what these lines actually mean. Why can't I write a 5 over here? All of them are circles. Why can't I just put any number wherever I want? All right, so that answers those questions. And then after they are proficient in carrying out that activity, you can get them to work on different numbers. But before you get them to move on to perhaps like 6, 7, 8, 9, 10, have them figure out what other numbers 5 can form. So get them to pour these 2 cups of cubes back into this cup, okay? And then have them pour different numbers into this, different number into this, so that they will see, oh, 5 can also be made up of 1 and 4. Okay, it can also be 5 and 0 if you pour everything here. Okay, and so on and so forth. So after they have done enough of those kind of activity, and because if you remember, they're not just conducting it; they are also practicing filling in to the number bond diagram. All right. So then, after you're done with it, you can get them to use the base 10 cube. Sorry, not base 10 cube. Base 10 frames. Okay, it's Saturday. All right, so get them to use the 10 frames, and then have them look at different numbers and explore the different combinations to see that what they do over here by pouring also relates to what they do and what they're familiar with in the 10 frames. Okay, so have them start with maybe putting 5 cubes, in this case counters, all right? and then figure out what 5 can make. So, or rather, what 5 can be broken up to. So 1 and 4, 2 and 3, and so on. Okay. And then the reverse, because just now we started off with decomposing, breaking up, we also need to help them understand that these numbers, when put together, okay, will make this total or the sum. Okay. So then you get them to pour it back, and then they see, oh yes, 4 cubes poured into this cup, 1 cube poured into this cup. So 4 and 1 make 5, and so on. Okay, so we always do, it's a little like a dance. You go forward, you go backwards. You always expose them to the opposite. Just like you teach them addition, you also teach them subtraction. Okay, so let's look at what we have next. Okay, I'm going to switch back to my slides. But before that, okay, no one's in the waiting room. And we'll continue with the next foundational idea. So, oh, no, it's still number bond. Okay, but I can't remember what I wanted to ask you. I think I'm going through perimenopause. Okay, so number bonds are not, well, what I've, all right, so it's not, number bonds is not just this, all right. Yeah, number bonds is not just what you see I presented, all right. It's also all these, all right. So in one of my Instagram posts, I mentioned that the mastery approach is one of the cornerstones of Singapore mathematics. So we need to make sure we expose children to different variations of representations. Okay. Instead of only showing them this, where is my laser? Okay, so instead of showing them this version of number bond with the total on top and then the parts below, okay, we have to also help them familiarize different versions of number bonds, how number bonds can also appear depending on how you break up the numbers, all right? So obviously any number except really, really small numbers like 2, 1, 0, okay, can be broken up into more branches. In fact, if the child wants to draw 8 circles and 8 lines to say that, oh, 8 can be broken up into ones, that's also a very good opportunity for them to see how 8 is not just able to be broken up into 2 separate numbers. All right, 8, if you break it up into 2 and 6, can be further broken up into smaller numbers. If they want, they can continue drawing more branches for 4 and 2 and so on. Okay. All right, now we're moving on to, oh, actually, before we move on to part-whole relationship, it is, well, it's 8:22 for me over here. It's 9:22 for you all. Let's have a 10-minute break, and then we'll come back and look at part-whole relationships, addition, subtraction, and other things. Okay, so I'm going to turn off my camera and my mic and disappear for a while. Okay, you should too. I will set my timer. Okay, so if maybe we all can set our timer together so that when I'm back, you guys know when I'm back. Okay, so I have my timer set at 10. I'm going to press start, and then I'll be back the moment the timer ends. All right, so I'm going to press start now. See you guys 10 minutes later. And I'll continue with part-whole relationships. So part-whole relationships is very often used in teaching whole no, word problems, okay, or talking about any story question, story problem. So why are they important in grade 1? So part-whole relationships teach children that every number consists of smaller parts. If you notice, this is quite similar to number bonds. All right, so number bonds teach children that numbers can be broken up into smaller numbers, into smaller value quantities. Part-whole relationships teach children that numbers can be not just broken up into smaller pieces or can be put together to make a bigger whole. All right, the part-whole relationships actually teach children that certain quantities actually look a certain way. So 3 will look smaller as compared to 5, and so on. All right, so children learn that numbers are connected rather than isolated. Questions to explore: what makes up this number, which you will see in my demonstration? What happens if one part changes? Okay, if we add another number, if we remove a little bit of, okay, just admitting people. All right, if we were to remove a number, especially in word problems, what is going to happen? How does the whole change if you were to multiply, if you were to divide, etc.? So it's important to learn part-whole understanding because it underpins addition and subtraction, bar modeling. Okay, for those of you who just started following me on Instagram, I will be launching my bar modeling for word problems program in early August. So look out for that if you would like to learn about bar modeling for word problems, right? Fractions and so on. And now we'll head over to PolyPad. Part-whole relationships. So when you're first introducing part-whole relationships to your learner, you try to help your learner see it from their perspective. All right. So if your learner's name is Jerry, let's say your learner is called Jerry, and then get your learner to grab 3 cubes. So start telling this as though it is a story. So Jerry has 3 cubes, and then your learner will giggle. He added another 5 cubes. All right. So he okay, if it's Jerry, Jerry would pick 3 cubes. Okay, sorry, before you read, he added another 5 cubes. So have Jerry take the 3 cubes and then join them together in a row. All right, after that, read, he added another 5 cubes. So then get Jerry to do the same to the 5 cubes, join them in a row. All right, so how many cubes did he have in all? And then have Jerry join all 8 cubes together, preferably different colors, just so that it's easy for the learner to see that it is 3 and 5. All right, and then have your learner talk about the size of 3 cubes and the size that's occupied by 5 cubes. Okay, and you can have your learner trace around 3 cubes and trace around 5 cubes. All right. Or if you would like it to be easier for your learner because your learner is still learning how to trace around, you can actually take, okay, so assuming you are doing numbers within 10, all right? So you, before you start teaching part-whole relationship, you can have, you can join 10 cubes and then trace around that 10 cubes, print it out, and also make different combinations of different strips of how 1 cube, 2 cube, 3 cube, etc. look like on strips of paper, and then have your learner place the paper over the cubes to see how much space the cubes actually occupy on paper. Okay, so that is another alternative if you realize that your learner is still learning how to draw around or trace neatly, right? Because otherwise some learners will trace around the 3 and make the size of 3 cubes bigger than the size of 5 cubes. There's always a possibility of that. So then, yeah, so talking about the size of how big 3 cubes, 5 cubes occupy, and then you can also get them to use a different color pencil and trace around the whole 8 cubes. All right, so trace around the whole 8 cubes and talk about the size. So which size is the biggest, or which number occupies the biggest amount of space? Okay, then your learner should be able to say 8 occupies the most amount of space, and then 5 occupies more space than 3. 3 occupies the least amount of space, and then talk about why they occupy different amount of space. Okay, because 3 is smaller than 5, 5 is smaller than 8, 3 is the smallest number. So use these languages to help your child, help your learner use different vocabulary words. If your learner is struggling with using the right vocabulary, but your learner actually knows how to read the words, you can have a piece of paper with the words printed out and ask your learner which word do you think is appropriate to describe these images or these sizes. Okay, so these are some ways to help a grade 1 child. Okay, in some curricula, these words are already introduced from kindergarten. Okay, that's fine, but I think it's important to provide enough aid to the children. So in grade 1, children are in Singapore, right? So in the past, during my time, and until I think late 2000, children were expected to be able to draw a part-whole model and solve word problem using bar modeling starting from grade 1. But the current Singapore mathematics syllabus has decided that they're going to push this to grade 2 when the children are ready to draw it independently. So this is how we can introduce part-whole relationship as well as the part-whole model in grade 1 by providing tools that they can use to mimic what they will be doing and drawing in grade 2. All right. So then we have this number bond over here. As part-whole relationship is very similar and closely related to number bonds because part-whole talks about the parts and number bonds talks about the quantity. They can also practice writing. Okay, that 5 and 3 will make it 8. So 5 when put together, okay, so 5 cubes when put together with 3 cubes will make 8, and 8 looks this big. Okay, so that is introducing part-whole relationship. Before we move on, wait, let me see if there's anything else after the slide. Yeah, so before we move on to place value, just wanted to ask if there's any question related to part-whole relationship. If not, let me switch my screen back to the PowerPoint slide. Can you all see the slides again? Okay, thank you. Okay, so let's continue. All right, so now we're moving on to place value. Okay, so after introducing number bonds, we introduce part-whole relationships. And then after part-whole relationships, when children have learned to count, learn to compare numbers, order numbers, and then add, subtract within 10, okay, beyond 10, so any number greater than 10 is when it becomes appropriate to introduce place value, because place value will introduce the ones, tens, hundreds, and greater place values, right? So that is why we only introduce place value after they are done learning up to 10. Okay, so why is it important in grade 1? So it's really important that children understand that any number they see, especially if it's a number that has more than one digit, is not just simply as a 3 and a 6, all right, even though it's pronounced as 36. So what does 36 actually mean? 36 is not just a 3 and a 6. It is 3 tens and 6 ones. So I'll demonstrate how we can go about introducing that. And in Singapore mathematics, we place a very strong emphasis on grouping in tens because our numeral system is based on the base 10, except for the clock, which is based on base 60, right? So we also place very heavy emphasis on exchanging ones for tens, which is required in learning regrouping and addition and subtraction, multiplication, division, representing numbers concretely, understanding value rather than digit names. So children learn that digits change value depending on where they are placed, especially in the place value chart. So why is place value so important? Place value supports the following concepts. Okay. Oh, no, it's not. Are you still seeing pothole? Thank you for alerting me to that. Okay, hang on. Give me a moment. Do you see place value now? Thank you. All right, let's carry on. All right, so yeah, place value supports the following concepts that are learned not only in later years, but in grade 1 itself, addition and subtraction algorithms, regrouping, etc. I'm not going to read all of that. Okay, so almost every computation depends on place value, as we can imagine, as we have performed them before. Weak place value understanding is one of the biggest causes of later mathematical difficulties. And this is really true and apparent, especially when they learn about decimals, multiplication, division, that requires regrouping, particularly multiplication of multi-digit numbers, division of multi-digit numbers. All right. So an example would be when if a child is not familiar with the magnitude of the number, let's say 3. Okay, let me write. So many children who have poor place value sense when comparing 3 and let's say 0.33, will tend to say that 0.33 is greater than 3 just by the fact that 0.33 has 1, 2, 3 digits. All right, so children, that's why place value is so important, because if they have been exposed enough to place value, even in grade 4, year 5, or before in Cambridge, okay, when they learn decimals, they should be able to tell that anything that has a 0 in a ones place will be smaller than 3 ones. All right, regardless of how many digits you are going to add after the decimal point. So then when they have a problem like this, they are naturally going to add numbers like this. They will also subtract numbers like this. All right. I've seen many of these sort of cases. And that's why we have to make sure we spend enough time on teaching place value, making sure that every child knows what a number actually represents, what each digit actually stands for. Do you, okay, wait, let me see. Yep. All right, so again, I'm going to switch my screen to polypad. This is my cue to switch my screen. So, okay. Now these are not supposed to be there. All right, imagine the child is not seeing this. All right, I'm just getting ready. So when you're introducing place value in grade 1 the first time, uh, and you are getting the child to understand what tens and ones are, what you can do is to get the learner to grab with two hands, two tiny hands, all right, as many cubes as he or she they can, all right, without counting. So let's assume the kid has very big hands for the age and managed to grab 26 cubes, all right. Okay, imagine these cubes are not laid out this way. So I've deliberately not messed them up and disperse them because I don't want you all to watch me put them back one at a time. Okay, so imagine all these cubes are scattered, and the child has grabbed two bunches of cubes that make up 26. The child doesn't know it's 26. Okay, so you ask the question, what do you think will be an easy way for you to find out the number of cubes that you have grabbed? Then the child will explore. Okay, it can be a bit frustrating for a child and you, because the child will probably not be able to figure this out unless they think about what they have been doing with 10 frames, and they realize that counting 10, 10, 10, whenever there's a nap 10, 10, and then a little more is a more efficient way. All right, so if they're that switched on, and I would say most usually if a child is able to associate 10 frames with this, most of the time is a very bright kid. Okay, so then after some frustration, you can give them options. All right, don't tell them yet. So give them options and say, do you think that putting them into groups of 5 or groups of 10 will make it easier to count? So don't tell them the answer, still give them options so that they can think and decide for themselves. So then the child would probably think of, oh yeah, 10 is easy because I know how 10 looks like. Okay. And then I just need to count the rest. So then the child probably would arrange it in 2 rows of 5, like a 10 frame. And then you encourage the child to put all of them in a column like this, so that from now onwards, it's the child start to learn that this whole row of cubes, okay, when put in 10 is a 10 rod. No, you haven't tell the child that this is a 10 rod yet. So after the child puts them together, you will introduce the term that this is a 10 rod. 10 rod. Okay. So then do we have enough cubes over here to put them into a group of 10? No, right? Then you will draw this place value chart, or you present the chart if you have it printed out, and say that we can organize numbers greater than 9, okay, and actually not just greater than 9, any number. We can actually represent numbers in a different way in a chart called a place value chart. All right, so we have how many tens? The child will say 2 tens. Which column do you think we can put these 2 rods in? Then I think it will be very easy for any child to decide to put it in the tens. Okay, if the child decides to put it in ones, you can have a conversation about it. Why do you put it in ones? Well, actually, it's not wrong, because this 10 is still made out of 10 ones. Okay, so agree with the child that it can be put in the ones, but if we put it in one group of 10, okay, we will consider them as 110. We see it as a group. All right, similar to learning the part-whole relationship, they are seeing this as this much. Okay, they're seeing the outline, the size of it as a 10. So this size represents a 10. Okay, and then this size represents a 1. all right? But many ones put together will make up a 10 or any number, all right? So then you'll say that these are ones because this is 1, 1, 1, and so on, all right? And so we will put the ones in the ones column. So then we'll ask them, what number does this make? So the child should be able to tell 10, all right, 20, and then 20. Okay, so that's provided the child already knows how to count in tens. If not, that will be a separate lesson. Okay, so 10, 20, and then count on 26. So that makes 26. And then the child can write 26. And then you can also use this to continue asking questions related to place value that they need to know. How many tens are there? There are 2 tens, right? It's obvious. How many ones are there? This is when they will say it's 6. But we all know it's not just 6 because these tens also make up ones. So if the child says 6, then we will ask the child, if there are 6 ones over here, do you think that these tens can also be broken up into ones? Then the child would think, okay, hopefully the child says yes. All right, then they can remove the cubes one at a time and then put them in the ones column. Unfortunately, they can't change the color like what I'm doing now. Okay, but they should be able to see that the size, provided they're using the same size cubes, that each of these are also ones. So this is to help them understand that in a number greater than 9, okay, it can be made out of tens and ones, and the tens can also form ones. So this will be how we introduce place value. Okay. Is there any question related to place value before we move on? So because this is a webinar, and I didn't know how many people are coming. Okay, I'm just conducting it as a something similar to a lecture, but in workshops, in trainings, there is actually hands-on activities by the participants also. All right, so back to the PowerPoint slides. Addition and subtraction. So this is the 5th and last foundational idea that I would like to share today. All right, so why is addition and subtraction important? And why am I not talking about multiplication and division? Because addition and subtraction are the two concepts that multiplication, division, and many other concepts build upon. So if a child is proficient in doing very simple addition and subtraction, especially within tens, within 20, it actually sets them up for learning multiplication, division, and the rest of these concepts. Okay, so fluency allows children to focus on problem solving instead of basic calculations. Usually children who are still struggling with basic calculation, even in year 4, grade 3, finds it very, very difficult to access higher level mathematics concepts. So in grade 1 and grade 2, so grade 1 and grade 2 are the two foundational levels in Singapore. So we encourage the children to think of these questions when they're dealing with smaller numbers. Okay, sometimes big numbers, but it depends on the situation, and I'll share with you what I mean afterwards. So which strategy is most efficient? Can I solve this mentally? Is there another way? So not all big numbers are difficult to solve. There are some big numbers can be solved mentally as easily as compared to smaller numbers as well. So now I'm going to use the slide for my demo. All right, so adding or addition using compensation. So if we have a question such as 29 plus 8. Oh no, actually, I do want to use polypad because I wanted to use 10 frames. All right, do you all see polypad? Thank you. All right, so I have 29 plus 8. All right, so I have 29 plus 8 over here. So this is to help children see why we don't have to use the entire 29 to solve this question. All right, so 29, the children can see that this is something very familiar. They know this is 20. We don't really need to use 20. We just need to use 9 and 8 in these two values to solve the question. So children who have already been exposed to using numbers within 10 to add and subtract, they will be able to see that you're essentially just taking like 9 and 8, add them together, and then you regroup. All right, so 9 plus 8. If we were to just take 1 from 8, right? Actually, let me move that up. I need a bit more space. Okay, so if we were to just take 9 plus 8 from 29, we can actually break 8 into 1 like I did from this 10 frame. So we break 8 into 1 and 7. And then we have 1 added to 29. Okay, we have 1 added to 29 to make 30. So now we have 30 over here, but we also have to remember that there's also 7 over here. So therefore, 30 plus 7 will give us the same answer as 29 plus 8. So this is an example of compensation. You are making 29 into 1 from 8, okay, and then adding the remaining. And then for subtraction, can apply the same as well. So let's look at subtraction. Actually, before we move on to subtraction, let's look at another question, right? Just to have another demo.
I have a question. Is that okay?
Yes.
What if I have a learner who goes 20 plus 17?
Yeah, that's perfectly fine. So there's no fixed way. I'm just showing you one of the many ways that the children are able to use. In fact, when we get the children to do this sort of question and we allow them to, let me put this back, and we allow them to use 10 frames, or they are capable of imagining 10 frames in their mind, there will be many different methods that different children will come up with. So that's why it's important to introduce the use of 10 frames when they're learning how to count, how to add, subtract within 0 to 10. Because in what supposedly in a classroom, in any math classroom, it's encouraged for children to talk about the methods that they use to solve any question. So a teacher can actually post this diagram, 29. Let me erase, remove the mess. Okay, so the teacher can present this on a whiteboard. A parent can present this, okay, on the table, and ask the child, how would you add these two numbers, 29 and 8? Then the child is free to move the counters around and figure out how the child actually wants to add and put the numbers together. So the child can, like you said, 29 plus 8 is actually 17 plus 20. So then the child could probably do, let me move from here just to make it look neater. Yeah, so maybe the child will move the whole 10 frame over here and see it as 20 plus 17. If that is what the child has figured out, it is not wrong. So we won't discourage the child from doing what he or she is comfortable and capable of doing. So that is actually a method that not many children use, but if they're able to see it, it's actually really, well, it's not just cool, but also it shows that the child has good number sense. So yeah, anyway, I was going to use 17 plus, okay, maybe 5, right? So 17 plus 5, if the child is capable of not having to refer to the 10 frames, then the child will be able to decide which number he or she wants to break. So usually we will have the child break the number that is smaller, because it is easier for the child to turn this into a 10 rather than turning 5 into a 10, because 17 is just 3 away from 10. So 5 can be broken into 3 and 2, and then just 17 plus 3, 20, and then 20 plus the remaining. So that is one mental strategy that the child can use in adding and subtracting. So for subtraction, we have 13, no, 15. Okay, and we're going to subtract 7. All right, so this requires regrouping. So we can start off by allowing the children to use 10 frames again. If you want to challenge some brighter kids, you can get them to use a different representation, maybe base 10 cubes instead of 10 frames, okay? Or even just get them to use cubes that are not put together to form rods of 10s, and ask them to try to figure out different ways to subtract. That's for more advanced learners. So 15 minus 7. So 15 minus 7, we are going to use what we call subtracting from 10. Right, so 15 minus 7, as we can see that there is a 10 on the left-hand side, and then there are 5 on the right-hand side. So because children should know that number bonds within 10 very well by the time they learn addition and subtraction, okay, they should be able to break 15 into 10, which is obvious from the 10 frame, and 5, and then use the 10 to subtract 7, which gives them 3. But because they haven't used the 5, okay, so 7 is gone. So you can ask them to take away the 7 counters. So take away the 7 counters to show 10 subtract 7, and then ask them what else is left. Then they can see very clearly it's 5, which is this, 5, and 3. Okay, so 3 plus 5 will be the answer for 15 minus 7. No, what am I writing? 3 plus 5, which is 8. So this is what we call subtracting from 10. I don't think there's actually this learning objective in Singapore math curriculum, but it's just a strategy that we use, and we name it as subtracting from 10. All right. Oh, okay. We have like 20 minutes before the end of the session. So let me go back to my slides. There's going to be a Q&A, but I would also like to find out from you all, what do you think is something that you want to try with your learner, maybe in the new school year if you haven't started, or if you have started teaching your child or your class? What will be one thing that you would like to share or try with your learner? Addition using compensation. Thank you. The rest of you haven't decided. Kaho practicing, yeah, practice using strips. Yeah. So so if you want to use the strips, yeah, you do need to have the cubes attached together, trace around, and then print them off. I think it would be good to get someone to help you cut them also. So now the Q&A. I'm sure a number of you will have questions. So Rafia Begum, if you have questions that you wanted to ask and I wasn't able to answer just now, this will be the time.
Yeah, ma'am. Thank you so much, ma'am.
No
So
problem.
your session was really very nice. It was
Thank
so
you.
impressive that we able to understood and we got to know that how what type of questions can be asked to grade 1 and 2 students so that we can get different answers from them. So my question was like this polypath I already came across, but is this accessible to every one of us? Is it free of cost?
Yeah, it is free of charge. So and that's,
Okay,
yeah,
got it.
it's really a perfect tool. If you're looking for virtual manipulative, there's another type of virtual manipulative that I would strongly recommend. It's called Braining Cam. I can actually show you right now.
Yeah, please, ma'am. And also, if possible, just share the link in the chat box so that we can also
Yep,
just save it.
sure. Okay, so
Thank you so much, ma'am.
no problem. All right, so I'm sharing the web link with everyone on the chat. If you're keen to have a quick browse as I'm talking through what it is about, okay, you can click on the link. So if you want to give it a go, there's an option to try the free 30-day trial. And
Got it, ma'am.
can you, okay, so yeah, so the free 30-day trial is up here. Can you all see what I'm looking
Mm-hmm.
at? Yeah, okay. And then there are manipulatives, which I can't remember if you can test them before you sign up for the trial. But I wanted to highlight that there are actually resources, okay, that you can go to choose. So under resources, if I click too fast, so you click resources, and then there are tasks that have already been pre-made for teachers.
Are you sharing that to us on the screen, ma'am? We are unable to see that.
Oh, am I not sharing? I'm sorry.
No, we can just see. Yeah, no, 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 no worries, ma'am.
Okay. All right.
Yeah, right now we can see.
So this, well, I started off with the homepage.
Yes, ma'am.
And then I mentioned that you can click on free 30-day trial, which will give you access to the manipulatives and the resources. Okay. I don't have a
Okay.
paid version now, but I will be getting this for my training courses. So if when you sign up for the trial and you go in to play with it, it the interface is very similar to PolyPad, but one thing good about Braining Cam that PolyPad doesn't have is the fact that you can actually share a code. So for those of you who have used games like Kahoot, Blooket, okay, Quizlet, you know that you can get your children to sign up to the, or rather just join a game by sending them a code, and then you can see how everyone is doing on the website. So quite similar to that concept, Braining Camp allows you to share a code to all your students in your class, and a it even shows you the screen of every child on the right hand side, so that you're able to monitor how your students are doing when you get them to manipulate different manipulators to conduct an activity. So let's say you are teaching how to read the time on the clock, okay, over here. So imagine you
Yeah,
share a
got
code
it,
with
ma'am. So, sorry to interrupt, ma'am. So this is accessible from which grade to which grade?
it's accessible
Uh,
to I think grade one.
till which grade can be used?
Here,
Okay,
yeah,
we have
grade
all over
K,
the grades.
grade K, kindergarten
Yeah, kindergarten too,
to even middle school. So middle school,
till grade 8.
yeah.
Okay, got it, ma'am. Thank you so much.
You're welcome. So yeah, it shows you the pricing over here. All right. Okay. Is there any more question from the floor?
Thank you so much for clearing my doubt, ma'am. It
You're
means a
welcome.
lot.
Okay, let me see what questions we have. Grade grade 4, a course to accommodate grade 4. I think at the moment I'm not producing any course for any particular grade, but eventually as as I go as I slowly finish off the Singapore Mathematics or Singapore Math Mastery course, there will be videos that I can share that is related to grade 4. Okay, not just share, but I will have to put a charge to it. All right, because otherwise it will not be fair to people who actually sign up for the course and then they pay for it, but others are not required to. So, Leah, have I answered your question? Which website? I think we were talking about Braining Cam. Okay, so Polypad, the website name or the web link for Polypad, yes, it's this. Oh, okay, give me 5 seconds. So Polypad website is on the chat. Okay, what to do if you want to see number bonds, which would it be? So if I had to use one material to build fluency for number bonds, which would it be? I would strongly encourage you to use base, why do I keep saying base 10 frames and any counters you can grab. All right, so you don't have to spend money buying any particular manipulative, but if you're able to get your hands on linking cubes, that will be perfect, because linking cubes are really useful in learning of many concepts, even area, okay, as well as volume and a little bit of exponents. Yes, so the base 10 rods, definitely, because children also need to know what are the number bonds within 100 in grade 1. We were just talking about grade 1. Right? So they should be able to see that 2 tens and 8 tens make 100. And then So some other easier to add numbers, they can place it. You can even ask them to draw the number bond. Let me show you on Polypad. Okay, I hope you all are seeing Polypad. Okay, thank you. All right, let's say we are looking when okay, let's say we're not looking at number bonds within 10, we're looking at number bonds within 100. And then they're learning, they should already know that 100 needs to go into this circle. By the way, this that I've clicked are the Cuisinart rods. These are good to teach part-whole relationship. Okay, so you can use this if you are, well, for you can use this if you're doing online lessons, but if you're doing live and in person, it's better to allow children to manipulate the concrete materials. All right, Anika, I see your hand raised. Let me finish this and then I'll get back to you. All right, so then, okay, they can show that some numbers. So get them to draw the number bond. Of course, draw bigger. I'm not able to shrink this any smaller, okay? And then they can see that certain numbers put together, okay, make 100. Sorry, it's a bit. All right, anyways, you guys can imagine I'm going to have 22 tens, 2 ones on the left, okay? And then, okay, perhaps not 100, but 50. And then I'm going to have 2 tens and 8 ones on the right to help them see that even with manipulatives, okay, that are not the linking cubes, you can also form number bonds. So on and so forth. All right, so Anika, go ahead and ask your question.
Okay, hi, Ms. Regine. It is Anika here.
Hello, Anika.
I want to know that the course you are giving us, is it? My kid is in grade 4, and she's like she's not very much interested in learning whatever grade 1 I teach, whatever I grade 2 I teach. So if I'm taking your course, is it will it be helpful for her since she's in grade 4?
I would say it will be suitable for parents who are going to teach parents and teachers, because it's an implementation course for grade 1 all the way to grade 6.
Okay, 1
Yeah.
to grade.
Yeah, 1 to 6. That's right.
Oh,
So if you just want to start from grade 4, then I think the course for grade 4 that's suitable for grade 4 will only be out. I'm just estimating it about maybe 6 weeks after the course starts.
okay. Okay,
Yes.
I'll wait for that. Thank you so much.
You're welcome. Okay, and I have another question on the chat. So, please pardon me if I pronounce your name wrongly, but Mr. Malari, I actually have a post titled, let me check. I think it's titled Lesson Demonstration on. Oh no, that's subtraction. But you're asking about addition. So grade 1 to complete 10, then add the, let's see. I might have it over here. Okay, let me use place value to explain. Would you like to give me an example of a question that you plan to do with your class? And then I can use that to show you how we can go about asking the question. Oh, so you're talking about I think you're talking about, was that the method I showed here? All right, so let's say 28 plus 5. So 28 plus 5, so perhaps when you're starting to get them to add, if this is the first lesson that you're having with them when adding within 40, okay, or within 100, you, do I have 20? Yeah, 28 plus. You can allow them to use base 10 frames, all right, and the cubes or the counters in the 10 frames, and help them see that when they're doing 28 plus 5. Okay, so if you're giving 28 plus 5, perhaps before you get them to do 28 plus 5, you can have them do 29 plus 5. Okay, because 9 is the closest to the next 10. All right, so 29 plus 5, when children are able to see this visually, they can see that 29 is really just one short of turning 30. So, all right, so 29 is just one short of turning 30. So then you can ask them, can we make, please excuse me, can we make 29 into 30 by taking something from 5? Okay, so because they have enough practice and they have um, enough memories of moving counters from one frame to another, or looking at how numbers look like in 10 frames, they can move one from the right hand side to the left and then see very clearly that it's going to give them 30. So the question that you can help them to decide is, can we move anything from the right to the left to make it into 30, or into the closest 10? All right, so then after they have done 29 plus 5, you can then change. If you downloaded my, okay, not downloaded, but if you requested the link for my mastery guide on Instagram, you will see that I mentioned, in when teaching children the mastery approach, you will tend to change one number in the equation to help them see a pattern. All right, so now that they see, oh, 29 plus 5 is just moving 1 over to make 30 on the left hand side, and then we have 34. Then you can ask them to help them see a pattern, right? Then what is 28 plus 5? All right, so 28 plus 5, we'll have to remove 1 from the left. Can we do something to 28 to make it into 30? Are we able to move something from the right to the left so that we have 30 on the left? Then it's obvious they can do it this way. Okay, then you write and show them we are essentially breaking it into 2, breaking 5 into 2 and 3, and this 2 will be added to 28 to make 30. So do we only have 30 as the answer? Do we only see 30? No, we still have 3 on the right. So 30, and if children can't say 33, they can count on from 30. Okay, 30, 31, 32, 33. So 30 plus 3, okay, it's 30 after we have added 2 to 28, plus the remaining 3 will be 33. Is that okay?
Quick question.
Sure.
I noticed that you use 10 frames and not the base 10 model or base 10 blocks. Is that intentional?
It's intentional because, well, it's intentional when they have not, when they have not learned place value, but also when they're adding, subtracting, just to help them bridge from what they are very used to, which is using the 10 frames to base 10 blocks or base 10 cubes. This is what I would prefer to start off with, and then slowly bridge it over to using the 10 rods or the cubes. So you will see that, okay, I'm not sure whether you have heard that in Singapore, teachers don't really use the textbook or the teacher's guide. I do refer, well, in any school that I've taught in Singapore, we are only given one teacher's guide per level because we don't use the teacher's guide. We just use it to refer to the scope and sequence, and maybe sometimes have a look at sample lessons and just modify and adapt from there. So as we teach different cohorts, we might come across situations whereby we realize, oh, we actually need to use what they have been doing since grade 1. The textbooks and the teacher's guide that are being written in Singapore or even outside of Singapore, they don't really show you every single concept or every single little intermediary lessons that you need to conduct, because otherwise the book will be as thick as an encyclopedia. So what I prefer to do is, yes. So then what I prefer to do to really help children bridge the gap as much as possible is to help them by using what they are most familiar, and then slowly move on to using other types of manipulatives. That's also part of the mastery approach. So if your learner, your students are very comfortable using base 10 cubes, okay, they can see the 10 cubes, all right? That is actually, the base 10 cubes are more commonly used when you are teaching them the vertical algorithm. So how we will bridge from base 10 frames to base 10 cubes when you teach them the algorithm is, I'm still going to use use polypad. All right. So this example, 29 plus 5, 28 plus 5, are just teaching them mental strategy. This is teaching them mental strategy. But when you teach them the vertical algorithm, all right, that's when we will start to introduce them to the algorithm using the base 10 cubes. So what we'll do is we will actually turn, I hope I can turn this. I don't think I've ever turned. No, I can't turn the base, the 10 frame. All right, so imagine the 10 frames are turned vertically. All right, instead of horizontal landscape format, you turn it vertically, and then you show the children. So and also, instead of using these circular counters, you can put the cubes in the 10 frames. I'm sorry, I keep saying them wrongly. So you put the cubes in the 10 frames. All right, you imagine you turn them vertically. All right, so in each of these boxes, you have the cubes. All right, and then you ask them to combine these on top to form the 10 cubes. Okay. If you want to make it even more intentional, you can have them have a row of blue and a row of red cubes, so that they can see that the 10 rod is made out of 5 and 5. Okay. And then slowly get them to change the color to all blue, because eventually when they use the small little base 10 rods, they are going to be blue, yellow, green, whatever color they appear in your classroom. So that will be how we can help them bridge between 10 frames to base 10 cubes. All right. Would I recommend Numicon? Yeah, Numicon is, well, we don't use that in Singapore, but in the school that I was teaching KS2 in Cambridge, they were using Numicon. Numicons are quite, I find it quite rigid. You can't really do anything to it. You can't break it. They can see that the circles, maybe 7 circles. Actually, I have it on PolyPad. Yeah, so Numicons, all right. I find them quite rigid. So they can see 1, 2, 3, 4. Oh, I can't count. They see 7 and 3 make a 10. All right. So this, I find that Numicons are good to teach subitizing. One look, they can tell this is 6 and 1, which make 7. And then this is 3. Yeah, so this will be good to teach number bonds within 10. It's 10:38. So, oh, right. So hands-on manipulative, do check out my last post on Instagram. I have a list of recommended manipulatives that you are highly encouraged to have if you want to teach the whole suite of Singapore mathematics. Okay. If not, I don't want to take up any more of your nighttime, afternoon, morning, wherever you are. It's a Saturday. All right. So enjoy yourself. Have a good night. And thank you so much for being with me today. Let me know if you have any question through my email. Okay.
Thank you so much.
You're welcome. Glad to know,
Thank you.
Devlin. I'll wait for you all to.
Thank you.
You're welcome.